Thanks, Aaron. Hi, everyone. I'm Sarthak, and I'll be presenting our work on the Internet of Unpatched Things. So the main aim over here is to basically look at the current state of devices. Like, we basically ended up studying network traffic from a bunch of smart devices which are really popular. And we want to talk about how these devices may potentially leak user information. My aim is to basically encourage you to think of how we can improve policies to stop this potential leak of information. So how is the smart home or the IoT environment very different from the conventional mobile or computer environment? The problem over here is that we have a lot of manufacturers, and we have small startups coming up with their own devices. They may be hiring novice programmers. Apart from that, these devices have low memories. They might not have capable hardware to enforce security protocols, which we use in computers and phones. This makes it pretty difficult to, first of all, implement security protocols on these devices. But apart from that, a bigger issue is that the current smart home model works like this. Your devices inside the home send all their information to the cloud to a particular server. In fact, if you have two devices in the home and they want to talk to each other, currently they'll talk to the cloud and the information will get back to the home. And something will happen in the home then. So what we have over here is a pretty bad combination. You have hardware which is incapable, and you have information which is always being sent to the cloud. So this combination results in potential privacy problems. So now, IoT devices which are sending network traffic without security protocols may end up leaking some information about the user. They may end up leaking information about what device is being used inside the home. And they may also end up leaking information about whether the user is home or what he's currently up to. So in a sense, what I'm saying is anybody sitting on your network path may be able to find out what you're currently doing inside your home. And this is a big fault. So what our aim is right now is to basically take up a few devices in our case study and study what kind of personal information or user activity information they leak to the cloud. So what we did was we basically bought some popular devices. We went to Amazon.com. We searched for like some very popular home network devices which people are currently using in their smart homes, and we ordered them. What I'm going to show you is like results for network traffic analysis for 5 particular devices: a camera, a photo frame, a hub, an Ubi smart speaker, which is like an Amazon Echo basically, and a Nest thermostat. So what we're interested in right now is what kind of information these common devices leak to the network. And the first device I pick up is the digital photo frame by Pixstar. So what we found out was that all traffic from this photo frame is sent in clear text. There's absolutely no encryption happening, all right? The cool thing is that this device can actually talk to your Facebook or RSS feed, so it's downloading photographs in the clear. And also, whatever action you take on this device, for example, you press a button, say you press the play radio button, that'll actually go in a clear HTTP packet, which somebody, again, on the network can read. So if there's somebody sitting outside on the network, like somebody in the ISP or a malicious passive listener, they can see what you're doing through the photo frame. Apart from that, it's also capable of downloading radio streams, again, in the clear. So an example of what kind of information we see, so these are snapshots from Wireshark, basically. And what we saw was that your email, which you configured your account with, is actually being sent in clear text. What this means is that this photo frame is potentially leaking account data. And anybody on the network path can actually have a look at this email. Secondly, if you press a button on this photo frame, say you press the list contacts button or the radio button, anybody, again, on the network path can have a look at what you currently press. So somebody on the ISP can go like, this person is currently listening to the radio from his digital photo frame, though I don't know why you would listen to the radio from the photo frame anyways. But so basically what I mean to say is that you can find out about the user activity as well as some account information just by looking at the network information. The second device we picked up was a Shock security camera. It's a pretty common camera, which is used for security monitoring in homes. It has like motion detection. What we saw was that all the traffic, again, was being sent in clear text. Now, this security camera actually requires a login. So if you want to view the stream, you're supposed to enter a password. But that doesn't mean the stream itself is encrypted. In fact, anybody sitting on the network can still have a look at where the stream is going and what the stream is. Also, if you go to the web interface and you press a button, whatever you did will still go in an HTTP GET packet, again, unencrypted. So videos are being sent as JPEG frames. Also, if you have pressed the FTP button, then all your data is being uploaded to the FTP again in the clear. And this is an example of what things look like. So the FTP is actually using some really random ports. So you can't really rely on the network to secure you again, because these are non-standard ports which are being used by the device. And things like this is basically private data which is being uploaded. The third device we ended up looking at was the Ubi. So this, I think, is like a precursor to the Amazon Echo. Basically, it's a small voice box which you can talk to, interface with other devices. For example, we had this Ubi interface with the Nest thermostat in our houses. So what we saw was that all voice to text, first of all, gets converted. All voice you talk to the Ubi will get converted to text on the device itself. And then text is sent in clear, again, to a server outside. The server here was the ubi.com. Apart from that, the Ubi also has certain sensors, for example, light sensors and temperature sensors, which are still sending their readings in the clear. And the interesting thing over here is when we interface this device with the Nest, it used encryption and spoke over HTTPS. But when it was talking to its own server, it was using HTTP, and everything was in clear. So clearly, this device actually has the capability of enforcing security. But somehow, the policy, whatever policy they came up with, they did not enforce encryption for their own device streams. Only when they're talking to the Google API, they enforce this encryption. So this is an example which shows how sensor readings were available. Now, these sensor readings can leak information about whether the light is on in the room or not. In a sense, somebody on the network who's on the path can know whether there's a user inside the room or not based on the luminosity value. Furthermore, like when we were chatting with the device, all the text was converted to clear text and then sent to the network. So here you can see an example of what the chats look like when I monitored them on a laptop gateway. The next device we looked at was the Nest thermostat. Now we're actually coming to the more secure devices, and the big ones too. The Nest thermostat from Google actually was pretty secure. All information was over port 443, basically using encryption and HTTPS. Now, what we also found out was that some of the updates incoming were in the clear, and we weren't sure why. So we contacted Nest about this. Turned out it was a bug, and they fixed it. So here's an example of what we found initially. Outgoing traffic was secure, but incoming traffic, some weather updates were not secure. They were in the clear text. They had some information regarding the location. And when we told Nest about it, they thanked us, and they fixed it. All right, and the last device, which I'm going to talk about, is the SmartThings Hub by Samsung. Again, a pretty popular hub from a pretty big company. The good thing was almost all the traffic coming out of this device or going into the device was totally secure over TLS. There was no clear text or port 80 traffic at all. And the flows were all to an Amazon AWS instance. But the interesting thing is, even though this device is in itself secure, and in fact, I see this as the model of future IoT devices, which are completely secure, there's still some background information, like 3 or 5 packets every 10 seconds, going to smartthings.com, which can somehow let you fingerprint the device. The good thing is that the SmartThings is a hub. Basically, what that means is that you have other sensors attached to SmartThings over some other protocols, like Zigbee or Bluetooth or Z-Wave, and you don't have a direct view of the sensors. So SmartThings itself makes all the information coming out of the house secure and then sends it out. But a person sitting at the ISP level can still find out that you have a smart things hub inside the home. So this brings us to my conclusion and some implications on the policy. Basically, I don't want to sound pessimistic or dramatic, but that's what the heading is, be afraid. We know it's really difficult to enforce security standards on smart devices. Inherently, I mean, there are multiple manufacturers. There are only a few big ones, but a long tail of small ones. Smart devices come up on Kickstarter and people buy them. It's difficult to ensure that they all follow the same standard. These devices are also sometimes very low capability. They don't even have a way to implement TLS on the packets they're sending out. And they also end up using non-standard ports and protocols. But the good thing is that we are trying to make an effort. For example, I found this handout outside regarding building security in the Internet of Things. And that's good, because it means we're trying to enforce security at the building block level itself. So maybe the new devices which come up would have security inherent in them. The second thing is, OK, so we've fixed devices which are coming up now. What about devices which are already present? How do we get people to patch them up or fix them? So first of all, we want to encourage people to look for bugs. And one way would be bug bounties. But as we've seen in previous talks, bug bounties might work for the big guys. But the IoT domain has a lot of small manufacturers coming up. And we don't really know if bug bounties will work for that. And whether the device will be popular enough to have users which actually look for vulnerabilities in them. So the main part is, how do we enforce such kind of things? Like, who's responsible here? Will the government try to enforce bug bounty programs? Or is it the manufacturer which goes if you find a bug, we'll give you money? And lastly, who pays for this patching and the update part? If this is using your network, is the user responsible for anything which goes wrong? Or the ISP? Or is it the manufacturers? So I want to end with some of the work which we're currently up to right now. So we've talked about how we can improve future devices in terms of their security and privacy policies. We've talked about how we can improve current devices by trying to find bugs in them and vulnerabilities in them. The approach we're taking right now is how to improve security and privacy policy on the network. Basically, we're trying to offload policy to the network layer. For example, in case of a smart home, all our information is going to go through a gateway which is inside the house. This gateway might be provided to us by the ISP, or it might be our own. But maybe there are parts of security which we can implement at the gateway itself. Maybe we can tell the gateway to enforce certain standards regarding the network protocols which are being used by devices. Or at the very least, this gateway could inform our user that, hey, there's something wrong with your devices, or this device is not using the right security standards. So what we're looking at currently is, can we offload device security to a gateway or the network layer? And secondly, how much information about the user behavior is actually leaked to outside the home network? All right, thank you.